next we are having pseudo first order reaction. Pseudo first order reaction, as the name says, that is a pseudo. Pseudo means false, I can say. So these are the reactions which are actually not a first order reaction, but they behave as a first order reaction. Pseudo first order reactions, they are actually of higher order. They have the higher order or rate of reaction. That means either they are second order or third order reaction, but they are forced to act or they are forced to behave as a first order reaction. So now let's see what we do so that the reactions start acting as a first order. So let's see the same thing with the help of some example. So example here, the hydrolysis of ester, that is I'm taking CS3, COO, C2H5. CS3, COO, C2H5. This is called as ethyl acetate. When it undergoes hydrolysis, means when it is added into water, it produces, the water is nothing but HOH. So during the reaction, what happened from here, the bond breaks. So that H attached to CS3COO and that OH attached to C2H5. So finally we get CS3COO, H attached to CS3COO. So we get CS3COOH plus OH attached to C2H5. So we are getting C2H5OH. So we are getting this reaction. Now in this, now let us write the rate law for this reaction. So rate is equal to, we have K into molar concentration of CS3, COO, C2H5. That is this reactant, and another reactant is water, that is H2O. Now in this case, when we calculated the x and y value, that is the powers, by performing experiment, we come to know that the powers are nothing but the 1. That is, for this also the power is 1 and for this also the power is 1. So rate is, so ultimately I can say the power is 1, 1. That means the reaction is going to be second order reaction. So currently I can say it is a second order. So actually the reaction is a second order reaction, but now the something is done so that the reaction start acting as a first order. Now what changes are done? Here the water is taken in excess. Water is taken in an excess. Whenever any substance is taken in an excess, means taken in a large quantity. Excess means more than required quantity. For example, suppose I require 100 ml of water, then instead of 100 ml of water, I am taking 2000 ml of water, that is 2 liter. So here that amount of water taken is very large compared to the amount of water which is required. So in this case, I can say whenever any substance is taken in excess, then rate of reaction does not depends upon the concentration of that particular reactant which is taken in excess. So now the constant rate of reaction will not depend on H2O. That means I can say, since water is in excess, H2O is in excess, therefore concentration of water becomes constant. That I am representing or writing it as a K dash. So here I can say rate is equal to, therefore rate is equal to K into, water becomes constant, so the water, instead of water I am writing K dash into this molar concentration of CS3, COO, C2H5. Both are constant, so let us replace these two constant by some third constant. Therefore I can say that rate is equal to K double dash. Instead of K and K dash, I am writing K double dash, bracket CS3, COO, C2H5. So the same reaction whose rate law was having two different reactants, that is CS3, CO, C2H5 and H2O, whose order was second. Now we can say now the rate of reaction depends only on with one reactant and with that too also with the power 1. So I can say that now the reaction is acting as first order reaction. So such reactions are called as pseudo first order reaction. The pseudo first order reaction, because the reaction was actually of higher order, this reaction was actually of second order, but by taking water in excess, rate of reaction becomes independent of it. So now it depends only on one reactant with the power 1. So now it is first order, and hence it will be called as pseudo first order reaction. Let's see, there's some more examples. Another example for this. Example number 2. A sugar is taken C12, H22O11. When water is added into this, sugar get converted into a mixture of C6H12O6 plus C6H12O6. Out of this, one is called as glucose, the other is called fructose. So when sugar is added into water, we are getting a mixture of glucose and fructose. Now if I'm writing its rate law again, so we have rate is equal to K into molar concentration of C6H12O6. The another reactant is H2O, so into H2O. The power of both is 1, 1. That is, the power is 1 for this as well as for this also 1. So here I can say again, if the rate of reaction depends on the concentration of both with the power 1, 1. So if I'm writing its order, the order is going to be 1 plus 1, that is second order again. Now in this process, again the water is taken in excess, suppose. If I'm taking water in excess, so again the concentration of water will become constant. So since H2O is in excess, concentration of water will become constant, that is equal to K dash. Therefore I can say the rate is equal to K into K dash. This K dash is because of the water, into C12, it's not C6, this is C12 actually, C12, H22, and this is O11. So now it becomes C12, H22 and O11. So now it depends only on one component, and that too with the power 1. So I can say that again it is an example. So again this reaction was actually a second order reaction, but after taking one of the reactant in excess, it becomes the rate of reaction depends only on one reactant, means it becomes first order. So such reaction, again it is an example of pseudo first order reaction, which was actually a second order but acting as a first order. So these are the example of pseudo first order reaction. So pseudo first order reaction is a reaction which is actually of higher order, means originally it's not a first order, but they are forced to act as a first order reaction.